Welcome back my dear friends, a very good morning, good afternoon, good evening to all of you, the students participants for this course NPTEL MOOC course, the title of which is Application of Forecasting Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you can all recollect and which I mentioned before the starting for any lecture, there are three main areas for this 30 hours course, which is spread over 60 lectures. The point 1 topic is forecasting, which you have finished. The point 2 topic is basically regression models. Even though it is written multiple linear regression models, we have covered regression models, which also we have finished in the 50th lecture. And the last part is time series analysis, and we have already completed one lecture, bit introduction of time series. We will continue discussing that for the rest of the number of lectures which is left for this course. So, as I just mentioned, we will cover time series analysis with some simple graphs and applications and discuss the main properties of time series and few different models. So, this is week number 11, lecture number 52. What is the coverage? We will cover different introductions and examples. And examples I will take for the time series some actual data taken from the stock market, which will be the best example of trying to give an idea about time series models related to finance data. Now, as we know, a time series in general is denoted by x suffix t, and x is basically the random variable which you are studying, but the suffix t basically means at which point of time. So, it can be t is equal to 1, 2, 3, 4 and it can go to infinity. But also remember, if you can recollect, in forecasting we have used the suffix that the values which was given by t there or it was given by I can either increase or decrease depending on whether you are standing at the tth time and want to basically predict for the future or trying to basically take the information from the past and then predict for the future. So, let me continue reading it. A time series denoted by x t, t is equal to 0, plus minus 1, plus minus 2, it can go, is said to be stationary if it has statistical properties similar to those of time shifted series, such that for each integer as you shift, the properties in general remain the same. And I will show you that with the example which I just mentioned, that it may not be true. And also we will discuss about the type of distribution which is important, because once we consider the distribution, it will be much easier for us to take them in the example. So, let us define x t as the time series such that the expected value is less than infinity and the mean value would be given by mu with which is a function of t, because that mean value will depend on the time period where we are basically finding out the mean of the time series. And also we will have a covariance. The covariance would be based on autocorrelation concept, which we have already discussed in forecasting. That also we will consider in few minutes. This time series x t is weakly stationary if the mean value is independent of time and the covariance function which we have is dependent on t for each value of h. H means that as you keep changing the time series, as you go step by step, that the covariance functions will keep changing depending would not change and it is independent of the value of t and for h. So, let me give you an example. As I said, for all the examples which we have done in forecasting, all the examples which we have done in, say for example, the area of regression models, all the data and all these things are in the Excel sheet, and I use very simple tools of Excel without going to new programming in order to basically illustrate the examples. So, let me go here for the time series. So, I have already opened the website. The website, if you can see, let me zoom in a little bit more. Yes. So, this is the website of Yahoo Finance and it gives you the Tata Motors Limited's stock prices in the NSE and the dates are given in reverse order. So, if you check this, the date is 15th and 12th and it goes on, and you have the prices based on, say for example, the time frame of, I will let me check, it goes on till it starts from September 16, 2024 till 15 September 2025, which is 1 year data. Now, 1 year data technically does not mean that you have each and every data, because considering the national holiday, considering the Saturday, Sunday and other things, there the prices would not be there, but we will just extrapolate that in order to basically find out what would be the prices for those whole 1 year and then do the work. So, that is what we should do. Before that, we will try to utilize the data, and I will copy the data and utilize it. So, I will go slowly. So, historical prices are there. I can, let me check whether I can. Now, I have to go in the historical CSV file. Just give me 1 minute. Let me take Tata Motors, or I will just copy it and read some data and then proceed accordingly. If I am able to get, just 1 minute. Let me open another site. So, if we are able to get the data, it will be much easier for us. Yes. So, we have the data start date, consider it is, first I will start with see for example, March 3rd, go to say for example, August 29th, update results. Let me see, because I wanted to collect the data from the source, from the net, and then utilize it accordingly, or else we will just copy it. It may take time, but I am sure we will be able to handle it. Just skip. So, let me open the file. Something has been downloaded. No, we do not have much of the data. Or else I can reduce the time frame. I can have March till May 30th, update results. Whether I will get it, I do not know. Let me it is not coming. Let me check this one. I will copy it, because rather than wasting time on trying to download it, I will get the data and do it accordingly. Just 1 minute. Yes, I will take the data. Oh, by the way, the data which I am going to take would be the closing price, because if you see this heading, you have opening price, high price, low price and closing price. There is adjusted close also, but if I discuss that, we will go into more in the realm of finance. So, I will skip that. So, I will take the prices for based on the data. So, I will copy it here. So, if I go to the time series data, so this is one of the time series which we will discuss about the dollar to rupee. So, I will take it for date closing price, and this is Tata Motors. In NSE. So, this would be taken here. I will move it one block here. So, this would be marked done. So, I will take the prices as here, right. So, I will put the dates in order of 1, 2, 3, 4 rather than take the one, because I will explain later on. So, I have the closing price, serial number, this is in rupees, and the prices are 9. I will take only without the decimal. So, 988, then it goes to 974. I am copying it here, and this file will be shared with you. Then 962, 967, then 970, 971, then 977, 963, 993, 993. Then yes, 974, 965, 925, 930, 927, 919, 919, 939, then 928, 930, 928, 917, 908, 907, sorry, 907, then 907, 891, 891, 910, 903, 879, 877, 877, 880, 864, 878, 842, 840, then 834, 843, 824, then 843, then just 1 minute, 843, 824, 835, 835, then 839, 819, 804, 805, 784, 786, 774, 771, then 783, 783, 771, 773, sorry, 773, then 783, 783, then 779, 779, 786, 790, 801, 788, 792, 8 816, 798, 799, then again 799, 786, 790, 790, 784, 790, 790, 779, 779, 755, then 744, 724, wait, 724, where is it, where is it, where is it? Oh, 744, 744, okay, 780, 771, 7 8, 784, 763, 754, 779, 774, 760, 742. Sorry for that, because I couldn't download it immediately, but from next time I will definitely do it. So, you have the data for this time series. So, I will make the serial number accordingly. I will come to the serial number and concept date later on. So, first I will do a histogram plot. So, when I do the histogram plot, yes. So, this is the histogram plot which you have. So, if I want to, there are small data. So, do not worry about that, and if I want to do have a look at the bin size. So, bin size is given as 65, number of bins is given as 5. So, let me increase it. So, for 10 the bin size the distribution this, for the 15 the distribution is this. So, now this is the time series data. So, if I plot the time series data, I plot, say for example, the time series part. So, this is the time series data which you have. But what is important is, if you see, the mean value is not constant, it is decreasing, but the fact is, what is important to do is with respect to the returns. Now, returns are generally calculated, I will write the formula. So, returns can be calculated in 3 ways. One is total return, which is denoted by the price of P 2, which is second day's price divided by first day price. Another is written as rate of return, which is given by the difference of P 2 minus P 1 in the numerator, 974 minus 988 divided by the earlier price of 988, and there is a return based on the time series, which we know as based on the continuous compounding interest rate. So, that is given I will use this rate of return as 1 based on the concept, and another is rate of return number 2. So, number 2 is given by the fact it is ln, ln is the log of P 2 by P 1. So, the difference between rate of return 1 and rate of return 2, where rate of return 1 is calculated by the ratio of P 2 by minus P 1 in the numerator divided by P 1, while the rate of return, let me change the spelling, rate of return which is given as 2 is given by ln of P 2 by P 1. So, those values would almost be the same if you check. So, now let us copy them. So, if I have these values, see for example, for 74 data points the values are given. Now, let us plot them, and this is what is interesting, and I will do a second stage of plot also. So, the first plot which I do is basically the total return and I mark it. So, this is the plot for total return. So, I will keep it here. Now, if I do it for the rate of return 1, the graph will look like this. There is not much of a change in the characteristics, only it will shift depending on the average value for the rate of return 1 and rate of return 2 in the long run would be 0, in the sense that it can be both positive and negative. So, they will even out in the long run. If I take for rate of return 2, also there is no change, because if you check only the shift would be for when the case is for the total rate. Now, what is interesting is this, if I plot the distribution, let me check, yes, histogram is there. If I plot the distribution, this is the distribution which will look like for the case of the rate of return 2. Similarly, if I find out the rate of return 1, it will almost look the same, no change. But if I look at the total rate of return, it would change, but not being very evident here, considering that the data size is small. Now, what I will do is this, and this is what is interesting. I take all the negative and the positive values for the rate of return 1. So, I put it here, I just copy them, then I sort them. So, let me sort them out from the minimum to the maximum. Yes, it is there. So, expand no, continue with the present list. So, these are the sorted one. I will also copy it for rate of return 2. Wait. Just copy the values, sort them from the minimum to the maximum, continue with the current selection. So, these are the values. Now, what is to be done is this: if I plot only the negative values and only the positive values, how they look, that you will understand. So, I am only plotting the negative values. So, this is the negative distribution for the case when you have no, I think I should do the general plot without going to the details of the, no, this is not the case. So, format bin width, number of bins, it becomes 10. So, the distribution would look like this, just white. Histogram plot, wait. Now, if I plot it for the negative values for the other case, it will not change, it will remain the same. But what is interesting is this. So, I have the negative return graph, rate of return 1, negative returns. So, the negative returns. Now, I plot the positive returns. So, the positive returns, if I plot, so I have the positive returns. Now, what is interesting is this. If you check the positive or the negative returns, they are skewed, number 1. Number 2, if I look at the distribution, let me open the Excel sheet and then make a here it will be easy for me. Yes. So, if I look at the negative and positive returns, I have the x axis at the returns, and this is, say for example, the probability of returns for one case 1, again for case 2, this is the probability of returns. So, these are R 1, this is R 2, R 2, R 1 are not the rate of return, they are for the positive and the negative. So, I will mark the positive part with blue, this is positive, and mark the negative part with red. And if I have the distribution for the blue one, see in the positive one, the distribution would look like this, and in the negative part, so one is skewed to the left, one is skewed to the right. Now, they are, I am spending a little bit more time on distribution, I will come to the time series part, because we have number of lectures which will definitely clarify. So, they are known as the extreme value distribution, and there are 3 types, type 1, type 2, type 3. Type 1, type 2, type 3 are basically the Freckett distribution corresponding to the Freckett distribution, Gumbel distribution, and the Weibull distribution, which gives you an idea based on the scale, shape and parameter, shape parameter, how would the distribution look like. Now, interesting is, if I have the combined distribution of the both the positive and the negative, very interestingly the distribution comes out to be almost normal, and that fact has been proved that as you are considering the total distribution, whether you are taking P 2 minus P 1 by P 1 or ln of P 2 by P 1, in the long run the expected value would be 0. And if you consider the variance for a big data set, the variance would slowly turn out to be not for any skewed distribution, it will slowly turn out to be for the case of normal distribution, provided the sample size is large. So, there are the discussions about the distribution will continue. So, with this I will end the 52nd class and consider more data. I will try to get the data in the 53rd class, such that the flow and the discussion can continue without any hindrance. Thank you very much and have a nice day.